This is Algebra 2, Prerequisite Skills. We will be solving systems of equations in two variables. So there are two methods to do this. We are going to be solving for the variables. We should get two solutions. And we are going to start off by doing the substitution method. Okay, so substitution means we need to isolate one of the variables in the two equations, and then we plug it into the other one. So here we have 2j minus 3k equals 3 and j plus k equals 14. So you first want to identify a variable that's easy to isolate. So j or k would be easy to isolate. So I'm going to get the j alone. So j plus k equals 14, so I'm going to subtract the k. So j is equal to 14 minus k. So now what I'm going to do is if j is equal to 14 minus k, in this first equation, instead of j there, I'm going to replace it with 14 minus k. So we'll have 2 times 14 minus k minus 3k is equal to 3. Now I can solve for k. So start by distributing the 2. 2 times 14 is 28, minus 2 times k is minus 2k, minus 3k is 3. So I have to subtract the 28 to the other side and combine our negative 2k minus 3k to get negative 5k equals negative 25. Divide by negative 5, so k is positive 5. Now if k is positive 5, we can plug that in right here to get j. So 14 minus 5 is 9, so j is 9. Now this is actually a solution like on a coordinate plane, so we want to write it alphabetically. J comes before k, so we'd say 9, 5. And then you do always want to check your solutions. So 9, 5, you check it right here. So 2 times 9 minus 3 times 5, does that equal 3? So 18 minus 15 is 3, so it works. J plus k, 9 plus 5, does that equal 14? Yep, so it works. All right, we will do another example of substitution. So here we have 5a minus b equals 17, and 3a plus 2b equals 5. That b is probably the easiest to isolate, so we're going to do that. So we're going to start by trying to get that alone. So I'm going to start by adding b to both sides. So 5a is equal to 17 plus b, and then subtracting 17. So b is equal to 5a minus 17. Now, if this is what b is equal to, I can now substitute it in for my other b. So I would have 3a plus 2 times 5a minus 17 is equal to 5. Now I can solve for a. So I have to distribute the 2. So 3a plus 2 times 5a is 10a, minus 2 times 17 is 34. 3a plus 10a is 13a, and then add the 34 over. 5 plus 34 is 39. Divide by 13, a is equal to 3. Well, if a is equal to 3, I can plug it right back into there to figure out what my b is. So b is equal to 5 times 3 minus 17. So 15 minus 17, which is negative 2. So this solution should be, in alphabetical order, 3, negative 2. And now we just want to check to make sure that's right. So we check in both. So the top one, 5 times 3 minus negative 2, does that equal 17? So 15 plus 2, yep, that equals 17. Bottom one, 3 times 3 plus 2 times negative 2, does that equal 5? So 9 plus negative 4, yep, that equals 5, so it works. If it didn't work, then you made an error somewhere and you should go back through your work. The second method that we will talk about is an elimination. Elimination involves you adding the two equations together to try to eliminate the a's or eliminate the b's. So first we have 4a plus 2b equals 15. Second equation, 2a plus 2b equals 7. You first have to decide, do you want to eliminate the a's or do you want to eliminate the b's? Here, I'm going to choose to eliminate the b's because notice they both say 2b. So if I can make one of them negative, my b's would be eliminated. So I'm going to leave the first equation the same. So 4a plus 2b equals 15. And I'm going to multiply the second equation by negative 1. So negative 2a minus 2b equals negative 7. If you multiply by negative 1, you have to multiply both the left and the right-hand side of the equation. Now you add the two equations together. So 4a minus 2a is 2a. 2b minus 2b cancel is equal to 15 minus 7 is 8. Divide by 2. So a is 4. Now you take that and plug it into either equation to get your b. So I'll plug it into 2a plus 2b equals 7. Well, if a is 4, 2 times 4 is 8. So this is 8 plus 2b is 7. Solve for b, so minus the 8. So 2b is negative 1. Get b alone, so divide by 2, so b is negative 1/2. So this means the solution should be 4, negative 1/2. Once again, always check your solutions. So plugging it into this top one, 4 times a, so 4 times 4 is 16, plus 2 times b, 2 times negative 1/2 is negative 1. 16 plus negative 1 equals 15, which is what it should be. Second one, 2 times a, 2 times 4 is 8, plus 2 times b, 2 times negative 1/2 is negative 1. That equals 7, which is what it should equal. So yes, this is correct. Now let's do another elimination. Next one, 3x minus 7y equals negative 14, and then 5x plus 2y equals 45. Now here, if you were to add these two equations together, our x's and our y's, neither would cancel, and neither of them look alike the way how they did in the previous problem. So what that means is we need to make them alike. So you're going to choose if you want to get rid of your x's or your y's. I'm going to choose y's here just because of the simple fact that the first one says minus and the second one says positive. So if I get them both the same number, they will cancel. So 7 and 2, you want to think what the least common multiple is of 7 and 2, and that's 14. So to make 7 into 14, you're going to times it by 2. So I'm going to times the top equation by 2. So this would be 6x minus 14y equals negative 28. To get the bottom equation, to get 2 into 7, or 2 into 14, you're going to times it by 7. So 5 times 7 is 35x. 2 times 7 is plus 14y equals, and then 45 times 7 is 315. Now you add these together. So 6 plus 35 is 41x. Your 14's cancel, and then you have negative 28 plus 315 is 287. Now to get your x alone, you divide by 41, and x here then is equal to 7. Okay, x is 7. I'm going to plug that into either equation. I'll just plug it into the bottom one. 5x plus 2y is 45. Well, 5 times 7 is 35. So 35 plus 2y is 45. Minus the 35. So 2y is equal to 10. Divide by 2, y is equal to 5. So the solution should be 7, 5. Now you always want to check it. So 3 times x. So 3 times 7 minus 7 times y. So 7 times 5, does that equal negative 14? 3 times 7 is 21 minus 35. Yep, that equals negative 14. So we're good. Bottom equation. 5 times 7 plus 2 times 5, does that equal 45? 5 times 7 is 35, plus 2 times 5 is 10. Yes, that equals 45, so it works. All right, we're going to do 2 more, and these two you can choose whichever method you want to. I'm going to use elimination more often than not, because substitution, I find a lot of times students mess up on their negative signs with substitution. So elimination just seems to be clearer, and it will work better in the next section. So here, 8x plus 2y equals 17 is our first equation. Your second one is negative 4x minus y equals 9. So I'm going to eliminate my x's here. So this is an 8x, and that's a 4x, negative 4x. So I'm going to leave my top equation alone. And the bottom equation, I'm going to times by 2, because 4 times 2 is 8. So that gives me a negative 8x minus a 2y equals 18. Oh, x's cancel. Ooh, the y's also cancel. So we have 0 equals 35. Will the 0 equal 35? No. 0 never equals 35. So this is no solution. Just to let you know graphically what's happening here is that we have two parallel lines. And we will get into more of that in our next unit. All right, and one more example. 2t plus 4v equals 6, and negative t minus 2v is equal to negative 3. I'm going to do elimination here again. I'm going to get rid of my t's. So my top equation I will leave the same. And my bottom equation, to make negative t into negative 2t, I'm going to times it by 2. So I'd get negative 2t minus 4v equals negative 6. Now look what happens. My t's and my v's cancel to give me 0. 6 minus 6 is 0. Will the 0 equal 0? Yeah. This is true all the time. So what this means is that we have infinitely many solutions. Okay, so if you get something that's true here, like 0 equals 0, it's infinitely many solutions. What's happening graphically is here's a line for the first equation, and the second equation is the exact same line. So every solution that lies on that line is a solution. And once again, we'll get into the graphs of these in the next chapter, so you don't really have to worry about that right now. I just wanted you to see what it would look like graphically.